Good morning, pre-calculus math fans. This is Madison with Dr. Hubbard's pre-calculus math group. I'm here to go over with you problem 41 from section 4.1. How to find the points between two touching circles. And we are given the circle 1 has a radius of 3 and it's centered at the origin. Then we also have a circle, the second circle, with the radius of 4 at the point 5, 0 as our H and K. Oh, look at that. It spells Keith Hubbard backwards. That name sounds familiar. Well, then, here's our equation for circle number 1. X squared plus y squared equals 3 squared. Because we have to square that. And the reason why it's x and y is because it's at the origin, and if it's at the origin, it doesn't go anywhere, so we don't have to use the distance formula. And this is actually not equal to 9, but it just means it's 9, and I didn't want to have to write out the equation again. For our second circle, we have minus 5, because the h is 5, and our formula says x minus h squared plus y minus k, but we don't have a k because it's 0, so therefore it's just y squared, and that is equal to 4 squared, which is equal to 16. I didn't want to bother rewriting the whole equation to get 16, so what I did was I went down on both sides. They connected in the middle because we want to subtract them from each other to get an x or a y. That's the only way it's going to work. You have to set both equations to 0, and that's what I did. I took x minus 5 squared plus y squared, and I moved the 16 over. There you are. So I subtracted the 16 over, and I subtracted the 9 over, and I subtracted them from each other. But if you're going to subtract circle 2 from circle 1, you have to have this everything in here the way you have it, with a negative sign out front of your parentheses. And what I did was I distribute. Shh! Don't tell. Professors hate that. But there's nothing. Or actually, sorry. Professors hate foiling. That's what I did. I foiled the negative. Or if on the professor's term, I distributed the negative. So I gave you negative x minus y squared plus 9. And basically at the bottom, I just combined them without having to write all that out. I just remembered that my x was negative, and so you still have an x. My y was negative, so negative y, or y minus y goes away, and then that 9 becomes a plus. Negative 16 plus 9 will give you negative 7, and it's still equal to 0. And now that you combine them into one equation and got rid of one of the variables that you can solve for x, you just move the 7 over, and you have x minus 5 squared minus x. And then you FOIL this out, and you get x squared minus 10x plus 25 minus x squared. And again, the x squares go away. And then you subtract 25, bring it over, and then you divide by negative 10. You have negative 18 divided by 10, which is 9/5. You go all the way back up here, and you pick either equation to put your x in. I put it in circle 1 because it's just x squared. It's not x minus 5 squared. And then I moved it over here and worked out to find y. So we go 9/5 plus y squared equals, and then you find a common denominator because you subtract the 9/5 from both sides. You find the common denominator, and you have y squared equals 36 fifths. Then you take the square root, so therefore y equals 6 over the square root of 5. Math professors really don't like that, so we have to change it and make it 6 square root of 5 over 5. And then therefore the points connecting the two circles are 4 fifths, or 9 fifths, excuse me, I can't read, 9 fifths and 6 square root of 5 over 5. And it also has to be negative. So it's 9 fifths and negative 6 square root of 5 over 5. And those are your 2 points of your two connecting circles. Thank you for watching this video. I hope you enjoy the rest of your evening. God bless you.